Vertex form. Again, in my opinion, this is the easiest. And we'll go over all the things you need to analyze with it. So the first thing is, this describes a horizontal shift. It will tell you to move to the left or the right. And we learned in Unit 1 that we're always going to go in the opposite direction than you would naturally think of. So move to the left 4 and create that axis of symmetry, sometimes known as the line of symmetry. Then we take that value of x equals -4, and we could plug it in and do the math, but the cool thing about this is one of the reasons I prefer vertex form is this back number tells you how far up or down from the x-axis do you shift to find the vertex. So from the x-axis, you're going to go up 10. So the equation for the axis of symmetry, sometimes known as a line of symmetry, is x equals -4. Your vertex for this problem is -410. And you can achieve that right from the equation. Again, that's why we call it vertex form. You can easily find the vertex. Okay, so because we're working with quadratics, I want you to think of the patterns here. 1 squared is 1, 2 squared is 4, 3 squared is 9. And we don't always even get to this one. Think of this as from the vertex, you're going to move 1 step to the left, 1 step to the right, or 2 steps to the left, 2 steps to the right of the vertex. And this number will tell you when you move 2 to the left or 2 to the right, for instance, it will tell you how far do you go up or down. If this number is positive, you move up. If this number is negative, you move down. Now, one thing you have to consider is this plays a factor. Each one of these numbers will be multiplied by this number. So instead of thinking of this as a positive 1, we now think of it as 1 times -2 is -2. And not 4, but -8, and not 9, but -18. Now, this pattern is going to help us to graph the quadratic function that makes a parabola. So I'm going to go 1 to the left and 1 to the right because it's symmetrical. So I go over 1 and down 2 because it's negative. So over 1, down 2. Over 1, down 2. Done. Then go back to the vertex and go over 2 to the left and over 2 to the right and down 8. So 2 to the left, down 8. 2 to the right, down 8. I know this is a distance of 10, just to speed this up. I know this is a distance of 10. So when it says go 3 to the right, I know this is already 10 and I have to go down 8. So I've already done 10, I just need to do 8 more. So over 3, down 18. There's 10 and 8 is 18. Over 3 and down 18. Now, as you connect these dots, make sure you don't have a sharp V at the very top, and make sure you have arrows heading down on either side. And now we're going to analyze it. We have to identify the vertex, done. We've identified the line of symmetry, done. The domain. All quadratic functions will have a domain of -infinity to positive. The range on this, remember you must do the smaller number first. So it comes from no limit on -infinity, and it goes as high as the value of y value of 10. We include the 10, parenthesis around the -infinity. Increasing and decreasing, always look at it from left to right. So from left, it's going upward, so it's increasing until you get to this turning point. And students, where they find the misconception often occurs, and talking about increasing and decreasing, they don't know if it should be in terms of y values or x. It's always in terms of x values. So recall that this is being pulled to the left while it's going down, and this is being pulled to the right as it's going down. So increasing, it increases from, there's no limit how far it goes to the left, so from -infinity, and it continues to increase to until it gets to an x value of -4. At -4 at rest, it turns into decreasing. And it decreases from -4, that's the x value, and there's no limit how long it decreases. So it continues to go to the right, which is positive infinity. End behavior, end behavior. So whether I am analyzing this from the left or from the right, in both cases, the y values are going down.